So I'm standing back there thinking, I'm glad the other guys went first, right? So as I'm standing back there, though, I'm nervous as ever. My hands are sweating. I'm like, oh, when's it my turn? So I feel like I'm on a first date or something. So bear with me as I walk through this, okay? I'm going to try and take it super slow. If I'm going a little bit fast, talking 100 miles an hour, somebody wave at me, my guys in the back, say time out or something. But what I want to talk about is this large measurement task. And forgive me for the bad cliche on the how do you eat the elephant one bite at a time. So this cliche, as I was coming up with this, so I got a quick story, I got to tell you guys this. We were doing a measurement job, dialing in tooling and doing some measurement on parts coming off the tooling with one of our clients from South. So all these guys came in, they came in for a long duration of time, 6 months or so. And they'd always eat at the same bad franchise, or they'd cook something simple inside their apartment or whatever. So one day I suggested, hey, let's go to this place local by us called the Grill Room. And it's this restaurant where you walk in, you pick your steak, and you cook it yourself, okay? So you can't complain about the cook, it's all done, you do it yourself. One guy said, I'm gonna take this lumberjack challenge. So this is a 42-ounce steak, he cooks it himself, and the clock doesn't start ticking. You get this meal for free if you eat it all, plus the fixins. So 42 ounces, plus all the fixins. Clock starts as soon as you eat your first bite. So as I'm going through this, I'm like, I gotta tell this story because this was amazing. This guy took this 42-ounce steak into multiple pieces, boom, and then the clock starts ticking, boom, boom. And it's all fun and games like the first 10 minutes. And then about 45 minutes into it, my wife was next to me here and he was here, and he was slowing down. So she's like, what's going on, you know? She comes from a healthcare background, so he's like, I can't swallow. And he must have had that food backed up to here. So sure enough, he's drinking water and he slowly made it through this thing, but within an hour, he finished this thing. Man, I was proud of him. He's eating all of us under the table, but his one bite at a time, I thought I had to talk about that because it's so different than this deal here. Okay, so I'll talk a little bit about us just for a second. So Diverse Dimensions, small shop. We're coming out of the west side of the state, out of Zeeland, outside of Grand Rapids a little bit, if you're familiar with the west side. And I gotta say this too, if I sound prideful at all, you guys, I don't want to be prideful. I try and be humble about this. I mean, the world that we all run in, I love it. It's cool. The hardware is cool. The software that we're talking about today, that's cool. My guys, I got most of my guys here, I take a bullet for them, you know. Just the stuff we do, sometimes it's simple to be prideful, and I don't want to be. But as I talk about us, so small shop, but we're on-site inspection and reverse engineering services. So we poke all over the world. We ship some equipment, we show up with a backpack, and you just start measuring. And it's amazing when you can pull something simplistic out of a backpack. I say that, but PolyWorks surely is not simplistic. But if you know what buttons to push, man, it makes a punch. So yeah, internationally we're around. I formed it back in 03, and I hate to be called president, Todd. It's funny. I'm not that's got such weird connotation now. So actually, my card doesn't have any title on it. My first guy I hired, when I used to be called the principal, and my first guy Tim said, if you're going to be the principal, I want to be the bus driver. So he wanted that on his card, and so we just say no titles. But I started it back in 03, and just love the work. I tell my daughters I do this for free if I could. It's just the best thing I could end up doing. So with that, and we talk about this big measurement task, this was a local integrator, and again, I've got to be careful on what I say, so I'm not as polished as the other guys for sure. If I use barnyard language, forgive me. If I say or if I show you something that looks kind of familiar, forgive me. I'm under intellectual properties and some confidentiality stuff, so I'm going to talk so generic, but I hope you guys get it. But if there's things that don't come out during the presentation, definitely ask a question, okay? And I'll tell as much as I can. And I'm going to drink water as I do it. But the first thing I want to do, instead of talking about the task or talking about the challenges of the task, I want to explain the assembly line to you guys first, okay? The complexity in that line, as I'm dry running this, and it's like how many times can you dry run this and kind of remember all this stuff, but as I'm dry running it, I'm explaining this, most of the feedback I got was, I don't know what you're getting at until you tell me what the machine is doing. So with the laser pointer, Gosh, I can see, I got that bald head up there. Look at you, see it on the screen, huh? I've never seen that. That's really cool. Look at this guy shake. Okay, so long assembly line in this thing. What happens is this piece of sheet metal starts at operation 10, and it traverses along. It gets some operations done to it. Then it traverses along and gets more operations done to it. So it's starting, and then it's working its way here as it traverses forward. So at each of these stations, though, what we've got are, I'll go one, oh, I can do it with my sticker. Look at this. Okay, I can do this hands-free with this. So each of these operations are a little bit different, and some are more complex than others. Like this one here, the piece of sheet metal, the bottom comes into this area here, and then this is an end-of-arm piece of tooling that a robot will come in with. And it adds another part of the operation or a part of the assembly. And then another end-of-arm tooling will come in, so the pinch welds will take place robotically around this. So there's some complexity here. When I look at this guy, he's pretty simplistic. This guy, this station comes in, it's pretty simplistic to start. But then what we see is end-of-arm tooling, and this huge gate that comes in that's got to be measured. And it happens on both sides of this frame or of this little assembly. Okay, so each one of these stations, each one of these 11 are all unique, which is fun. I love that. I like the diversity. Forgive me for that. I don't mean that to be punny or put me in the penalty box. Diversity, I love that in what we do. So, but now I'm going to talk about the challenges a little bit. So you got 11 of these stations. We had some time constraints that we were up against. We had builders that were in this area. We had guys that were doing controls engineering on the robots. So we had a certain time constraint when we can get in and get out of these tools. And then the other thing is there's a ton of content here. There's 11 stations, but there's also side effective frames and gates and end-of-arm tooling. It was cool. It was a good complex project. So when we got this project to start with, we let it marinate a little bit with all of us guys in the shop. And how are we going to approach this thing, you know? And we said, we got to chunk this thing up. There's no way we're going to spank this out in 2 weeks and not divide this thing out accordingly, okay? So what we did first, though, we did a little bit of model prep back in the lab with PolyWorks. And it made it easier when we could see at least the CAD model. We had no idea what we were up against until we got to the plant floor. But our first step was to dial in the entire operation. Each one of those little stations had to be dialed into a gravity plane. So the laser tracker works awesome for, whoa, whoa, whoa. Okay, and we go back and go forward, hang in there. This right here, so we've found the spot. In fact, I've got the CAD showing here because that was kind of the view we were looking at. We spent minutes or a little while trying to optimize where to put that tracker to see most of the line. We didn't want to move so much. We knew we could and we had to, but we wanted to see the most of the line as we could. So we found the optimum spot for the tracker. And it looked straight down this thing. It seemed like a mile, man. This thing was a mile away. You could see all this tooling in there. It was a cool sight to see as we were putting this all together. So for us right now, we're setting up the gravity plane, and each one of these stations had to be split in a distance to each other, and they had to be in line with each other. So the tracker did that pretty well. But there was a couple features that we just couldn't see. No matter how we had that tracker set or how mile high in the air we could look down on it, we just couldn't see everything. So what we ended up doing is we knew we'd have to leapfrog some arms in. Okay. When I say that, I'm preaching to the choir, right? I mean, all you guys have probably done a leapfrog or done a movement of a device position. So it's like, you guys are all brothers of the woods, I say, or brothers or sisters of the woods. So you understand this. But what I'm going to kind of talk about is, I wouldn't pick any other software. I love the way PolyWorks handles multiple device positions in the same project. So here what we're doing is we're tossing an arm in just to get another couple of the pins that would form on this 11-piece line. So we did it in one position here with just a leapfrog to targets. And then we had another position that we had to do this in as well. So what we did with the trackers, we set up multiple targets, leapfrog devices. And then we would shoot the couple pins or whatever we needed to remaining. And then we'd keep the arm here because we'd have to dial in the fixturing at that point as well. So here you can see just another arm in place here. We've got some mounts that we make. We've got a list of accessories. After doing this a few times, we found out there's a cool thing that works here, but that doesn't work here. There's a cool way to mount to an I-beam, but that doesn't work here. So we've got a few accessories. So if you ever get into a measurement spot, you want a little hand with some ideas on how to mount stuff, man, we've probably licked it. So the third thing we did then is, after we've established the alignment, we would put multiple arms into the station. So again, this sounds prideful, but I don't mean it to be. So I've got 15 arms, I've got 9 guys, and we've got 6 laser scanners and a tracker and some other stuff. But it's cool when you can show up at a spot like this with that much horsepower and head spin. And when you can start to measure so quickly to a gravity plane, head spin. All the builders are like, whoa, this, we got 2 weeks to do this. And by day 2, we were already into some of these operations with the arm. So it's powerful software, and it's so easy, and it's so well organized in the software that we just love it. Okay, so this would be a view where we'd have an arm like right in the middle here, suspended in, and we'd be measuring all of this equipment. So the fourth thing, though, the big step is, so 2 days, 2 of us guys would be getting the gravity plane, getting the alignment settled, and getting all of these leapfrog targets out. Day 3, here comes the reinforcements, man. All the horsepower off the bench comes in. These boys are wheeling all their stuff in. They got arms and all kinds of stuff. So what we did then is we would hand off thumb drives to each guy. So each operation would have its own project, okay? So we kind of determined this was a good way to divide and conquer this thing. If we could bite-size piece this thing, each tech would get their own project, their own operation. Because what we found out is it was so cool to divide out that CAD. The CAD models were massive. So we had all kinds of slow times at first with the CAD trying to get all these pieces in. We said, bite-sized pieces, man, we got to get rid of half of this stuff. And then when you've just got Operation 20, okay, now we're better. So I'm excited about the V18 with the CAD organization, or how that's going to be parceled out. So that'll be good to see. But the same thing is, we would have multiple positions. Each tech just took one and he said, okay, I'll take Op 50 today. Or, oh, I hear that Op 20 is going to have some builders on it today. Okay, cool, I'll go to 30. And so we had some flexibility there too, okay? So to talk about a couple of the benefits of this, I've mentioned a couple of them too, but the time constraint, it was minimized because we had all kinds of techs doing this thing. If we have that much horsepower back at Diverse, we can say, okay, as many as we need. Let's come in with 6 and see if we need more, we'll pull them in. So we minimized any kind of time constraint based on the amount of techs that we could throw at this thing. Sometimes that's good, right? You throw all the resources you can at things. But the second one is this convenient delegation of work. So it's not like we had to be sequential in how we took these operations. We did whatever worked for the build guys or the controls engineers. We could show up and start working for a little bit. We'd leave an arm in place. Then if we got to a point where they had to change some of the cylinders or some action on a robot, we'd move to the next one over. So it was super easy and convenient to do that. And again, the size of the PolyWorks projects we kept pretty minimum because we blew out a bunch of that CAD. Less downtime. Yeah, this was interesting too. Except first we had some trouble where when you're a mile away and that tracker's looking down the pipe, all kinds of build guys would walk in front of that. So we'd be trying to measure and we'd have some interruptions with that. So it made sense that when arms got into place and we could measure individual operations with an arm, no worries about the CAD or the tracker beam getting interrupted. Less variation because we had every tech would have the same exact alignment. So when we delegated out projects or handed them out, every alignment was the same. It was the alignment back to the CAD model and using the gravity plane or the level plane as its primary. So we had less or better reduction in variation based on that. The tracker drift, we eliminated this too. We only were on this for a couple days, so we had the tracker drift pretty much eliminated because as soon as we could, we got out of using the tracker in that operation to do the leveling, and then arms would come in with that set alignment, so we eliminated the tracker drift. And I had to put that talisman in there, it's so funny, but that's an amazing piece of whatever. But you get this thing on your arm and you can walk around and you can tell what device is live and you can measure, and we're talking through walkie-talkies and it's like dude, that's cool. You're on that thing. I see you, man. You're doing good. And okay, go, yeah. And it's just it's a fun tool to use when you've got that much spread between all your guys, okay? So that's it. That's the bite-sized piece thing, how we delegated this thing out. So if there's any questions, I don't want to get too much into the product or the client or my client's client, but any questions you guys have about what we've done. And again, the leapfrog, you boys or you people have probably done that a million times, and it's efficient inside of PolyWorks, so we utilize that all the time. Any questions at all?
Questions, please raise your hand. We got a question here. Third row.
Could you please tell me, okay, how many relocations did you have totally?
I don't understand. Say again.
How many times, how many device position you used within your project?
We'll talk later.
Okay, the related question is, what's the overall error?
Oh, so I would say we're between 5 and 10 device positions.
Okay.
And each of the devices was using that same exact alignment. So the device position error was localized just in that area. So microns, whatever, an arm, because we use so many, I can't remember off the top of my head, but once we use the pucks on the SMR and we start measuring that in, each station would have its own. So we never exponentially made it worse. We didn't additive. We just used each station would have its own.
And from your presentation, I understood that your primary datum or primary datum feature was a horizon. You use it like that.
Correct.
What was your secondary and tertiary?
All the pins, good point too, because that's why we had to measure all of those pins on those 11 fixtures, like their main datum pin.
Okay.
And there was a couple there was something in the way, some sensors. I'm like, gosh, we got to find it, because if we can get this all with one shot on the tracker, we could do it in a day. And we couldn't. So that's how we leap, or do you call it leapfrog in the past? We leapfrogged into this position on 2 operations because of that stinking pin. We just couldn't see it. So and then we just left the arm in that position. And then as soon as that was in the same project too, so then as soon as that alignment was cemented, then the thumb drives went out.
And did you do anything to, recognize potential device movement? Let's say you did something, you stopped for whatever, for lunch, returned back. How did you do, like, again, device position to check that you didn't move in that time?
That's how we look at the tracker drift. So we do that leapfrog back in to eliminate that tracker drift. So yeah.
Thank you.
Yeah, that was a fun project, I tell you. It's fun to see all those targets out there, I almost called Barry Golden, borrow some of his. Yes.
I was just wondering how you came up with that many pieces of measuring equipment. Did you own all those, or did you rent them?
I know. It's a pain in the ass. I hate paying the warranty on it. But yeah, so get this. So I started.
You own all of those?
Yeah.
Oh.
Bought them, or I started in 03 and just keep going,
Any more questions? Looks like no. Well, with that, Jeff, thank you very much.
Thanks, guys.